How's it going, everyone? Welcome to the next lecture in which we're going to tackle IP addresses. And I would argue that this is one of the most foundational but also the extremely important topic when it comes to OT and networking in a general sense. So IP addresses are going to be assigned by engineers and technicians to all devices that are going to be part of the network. Therefore, it is extremely critical for you to understand and follow the concepts that we will be talking about today. Now, of course, this is going to be a hands-off theory type of a lecture where they're going to proceed with a couple of different labs as we explore the switches and some of the other devices and their functionality. So here, I really want you to pay attention to the theory before we can apply it in practice, because it's extremely important to understand some of the nuances of IP addresses that you may not necessarily experience until you're going to be working with real equipment. So going back to the hardware that we've already seen, so this is a PLC, we have a VFD here as well. The fundamental question is, why do we need IP addresses? And this goes back to our discussion on networks. So the goal of a network is to be able to pass data and information between different devices. And so as we had connected our laptop to the VFD, we were able to ping it, but that's basically just a check for being able to communicate between the laptop and the VFD. In order to pass information, that's going to take a little bit more programming, a little bit more software, but you need to know the address of the device that you're communicating with. And so that is where the IP addresses come in. So again, if we illustrate a basic example, so we will have a PLC rack, and then we're going to have a VFD and perhaps an HMI. So this is as simple of a machine that you will notice or see on the OT side. And so the PLC is going to have communication to the VFD, and then the PLC is going to also communicate to the HMI in order to allow the operator to, for example, start and stop the machine, in order to change certain parameters. But basically, you can communicate from the HMI to the PLC, and you can communicate from the PLC to the HMI to the VFD, and there's going to be a general flow of information between the devices. Now, as to you want to make the HMI talk to the VFD or the VFD talk to the HMI and the PLC, that's going to be a different discussion. But in order for those packets to go from one device to the other and vice versa, they need to know what the address of the destination is. And so that is where, like I said, the IP addresses come in. So remember that MAC addresses are going to be static. Each piece of hardware is going to have a unique piece of identification on the MAC side, but it's also going to be typically pre-programmed with a certain IP address. And again, that depends on the manufacturer, depends on the data sheet. However, you will need to configure an IP address. So let's look at the example that we had in the past. And so in that case, we had a 192.168.1.7 assigned to this VFD, right? So that was the IP address that we had. And let's assume that we have a laptop. So here I'm going to just draw this line, and we had a laptop that was assigned an IP address that I gave it. So 192.168.1.100. And so the first question that you may have is, why did we pick that specific IP address? Why 192.168.1.7? How did we know to select that for the VFD? And so the rule of thumb is, by definition, each octet, right, so each basically segment of your IP address can be set to anything from 0 to 255, right? And so in theory, we could have picked the address of the VFD to be 0.0.0.0, and we could have set the laptop to 0.0.0.1. Now, that would have been possible. However, there are generally standards and recognized IP addresses in the general sense, and there's no reason for you to memorize them, but 192.168.1 or dot something, dot whatever is going to be a standard IP address used in private networks, right? So the way it works is, we've discussed this a little bit at the beginning of the lecture, but you will have your ISP connection or your internet provider that is going to provide you with usually one IP address that can be static, sometimes it can be dynamic, but basically they will give your location, so your home or your office or your business, one IP address, right? So I'm going to put that as just one IP address that they will take from the pool of IP addresses available to them. Now, internally, you can have multiple devices. You can create your own networks as wide as you need. Data centers could have thousands of different devices. You could have virtual devices. You can have containers with specific IP addresses. But the point here is that your network is basically yours to configure and yours to maintain. So you, in theory, can assign whatever IP address you would like to whatever device within some constraints into which we will get into in just a moment. But the general answer is you can assign anything from 0 to 255 in every octet. So basically you're going from 0.0.0.0 all the way up to 255, 255, 255, 255. Now, as I've mentioned, 192.168.1.x is a commonly used scheme for private networks. And to give you one example in terms of practical OT knowledge, a lot of the Allen Bradley hardware, so not including the PLCs and some of the VFDs, but when you look at, let's say, Point.io or Ethernet cards that you will find on the control logic side, you will typically find a set of dip switches. And if you read the data sheet, a lot of times what can be done if you don't have access to the software, right, that's going to be bootp or rslinks or via the web page for that specific card, what you can find is, like I said, a little set of dip switches. There's going to be 3 of them that allow you to basically set the IP address, and that's going to be only the last octet, right? So in that case, if you have a VFD with the dip switches, you can set it to 192.168.1. Anything you'd like from 0 to 255. And why is that important? Well, because then you can take that into consideration and design machines and networks that will allow the technicians and engineers to easily swap out parts. And so basically what I'm trying to get at is that it is an easy to use scheme, at least in the world of Allen Bradley and other vendors that have provisioned hardware for the private networks. Going back to IP addresses, right? So I'm just going to erase a little bit of what I've already explained, and let's just dissect this a little bit more, right? So I've mentioned that there's going to be 4 octets, so 0.0.0.0. So just like your MAC addresses, this is going to be represented with dots between each octet, and each one can go from 0 to 255.255.255. 255. And so you can then select a different IP address for each one of your devices. And so if we want to go back to the same scheme, just to be a little bit more practical, this basically means that I can start with .0, I can then have the exact same 3 octets, .1, the same exact 3 octets, .2, so on and so forth. So basically what we're trying to do here in assigning these IP addresses is to allow the devices to be on different, which is a requirement, IP addresses, so that they can send packets between themselves, right? So this could be your PLC, this could be your HMI, this could be a VFD, but they're all able to communicate on the same exact subnet, right? And subnet is something that I've called out a little bit in some of the previous lectures. We'll get into that in just a moment, but basically they have the exact same 3 first octets with the last one changing or incrementing. Now, again, there's going to be some nuances. So generally speaking, you do not want to utilize 0. You do not want to utilize 1 because 1 is usually assigned for gateways. You do not want to utilize 255. So you have a little bit less devices on that network, right? So this is where subnet masks will start to come into play. And I am intentionally jumping a little bit as I explain some of these concepts because they both build on each other, but are also important to understand as you're going to be setting up the devices. So let's go back to, again, the fundamentals. So we have a device that we've set to 192.168.1.7. The first question that you should have as you see this IP address is, what do I need to set my laptop to in order to talk to that device? And so like I mentioned, this is where the subnet mask is going to come in. And maybe you remember, maybe you don't, but it was set to 255.255.255.0. And what you will notice by simply looking at our graph here is that the last octet of the IP address is going to correspond to that 0. And what this should indicate to you as you're working with IP addresses and subnet masks is that your laptop, in order to communicate to that device, needs to have the exact same 3, in this case, octets, right? Because there's 3 255s to communicate with our device. So we could have picked 100, which is exactly what we did. We were able to successfully ping that device. We can also select 200. We can just as well select 10, and we can set just any variation of the IP address as long as it's not 7, because at that point we will have a conflicting address and it's going to cause all sorts of different issues depending on the device. So anything that is not 7 would have been allowed to talk to between two devices. Similarly, if we wanted to add an HMI and a PLC to talk to that same VFD, we could have selected anything that is 192.168.1.8, for example, .9, .10, so on and so forth, as long as there's no conflicts. Now, the question becomes, obviously, on the subnet mask side, well, why do we need to set or limit ourselves to those 3 last octets, right? And the answer is, you don't have to. So you can very easily remove this 255 and replace it with a 0. And so now you have a subnet mask that allows a greater number of devices. And let me explain that a little bit, right? So in the first scheme, remember that we can set this from 1, or let's say from 0 to 255, just to maintain simple math, which basically gives us a total of 256 devices on this specific subnet. Again, like I said, excluding the gateways and a couple of other devices, but let's assume it's 250. If we are going to set the second, right, the second value of the subnet mask to 0, we now have basically 2 variations of 0 to 255. And so if you've done permutations in mathematics, this gives us a 256 times 256 permutations, right? And how does that work? Well, 192.168.0.0 is going to be the first one, so this is going to be 192.168.0.1, same thing, .2, all the way to 192.168.255.255. So think of it as you increment just like you would in normal decimal variations, the numbers at the end, then it overflows to the other one, and so on and so forth. Therefore, you have all these permutations of how many IP addresses and ultimately how many devices you can have on that network, right? And so immediately the question becomes, well, why don't we just set the entire subnet mask to 0? Because at that point, we can just have a basically infinite, just a very large amount of devices, right? It's going to be 256 to the power of 4 number of devices. Why don't we just always set it to all zeros? And there's a couple of answers as to why you don't want to just have a vast number of devices on your network, including on the OT side. But number one is you're going to run into traffic issues, right? So depending on which hardware you're using, what kind of traffic you're sending, if it's motion traffic, if it's going to be vision systems traffic, if it's going to be anything high speed, you're going to very quickly run into different bottlenecks. So for that purpose, and we're going to talk about segmentations of networks a little bit later, but basically you need to have a set pool of devices, for example, on a specific line, or perhaps for a specific application, like I've mentioned vision. So maybe all of your vision systems are on a single subnet. And the second point is that you generally want to limit the pool of available IP addresses as much as possible to reduce the threat of possible attacks, right? So if you have all IPs can be set to anything whatsoever, it's going to be really easy for someone who's going to connect to this network maliciously or otherwise to just pick a random address and go to town on changing some of those parameters. So again, this is not going to be unique to malicious intent. This is also going to be, you know, if I plug in, for example, my laptop just to see the internet, for example, onto a plant network, and I have an IP address that's going to be set by usually DHCP, But if everything is open, it's just going to pick the default IP address, and I'm going to disrupt operations in that specific setting. So that's the reason why it is not very common, or I've never even actually seen this in my experience, to set the subnet mask to 0.0.0.0. Now, this is a little bit oversimplified, and the way I've oversimplified this is that I've put zeros in this case. If you want to get a little bit more granular, and there's a lot of videos on this explaining, I guess, what's possible, but in a nutshell, imagine that if this is set to 0, then I can, as I've mentioned, set the IP address from anywhere from 0 to 255, right? And so this can be set not only to 0 or 255, it can be set to any range of the values. And those values are represented by 8 bits. And so here I'm going to write this out, right? So this in binary, and again, you can spend the time to learn how to convert from binary to decimal or to hexadecimal in case of MAC addresses, but basically this is your 255, right? And so in this case, if I've set it to 255, again going back to 255, 255, and then 255.0, like I've said, you then go back to the scheme where you're allowed to set the last octet from 0 to 255, and so you have 256 potential options or devices on that subnet. Now, like I've mentioned, what you can do is you can set, for example, this last bit to 0, and in this case, in case of a 0, you now have 254, and what is the impact of that subnet mask is that now you have basically 2 bits on this side, so your calculation becomes 256 times 2, right? And so now you have, what you've basically achieved is that you have 512 devices on your network, and it allows you to extend the pool of devices. Likewise, if you set the second bit to 0, you've again reduced this basically by a factor of 4, right? So this is basically binary, so it's multiples always of 2, and in this case you're going to do 256 times 4, and this is 1024, and of course this follows the same pattern that you would see, for example, in your memory, in your RAM, and generally speaking, you can set your subnet mask to whatever you need in order to accommodate a set of devices. This is not very common and can confuse, or is, I guess, a lot easier to confuse engineers and techs troubleshooting equipment if it's going to be some kind of a weird scheme, but in theory, you can do it. Now, the other thing that I want to mention is that, again, so here, on a total level, right, so you have 4 octets multiplied by 8 bits, so ultimately you have 32 available positions. And so when you look at some of the drawings or maybe some of the specifications of your system, you will have the subnet mask specified after the IP address. And that's going to be specified by the number of ones that are going to be representing that specific subnet. So what I mean by that is, for example, if we have this set to 255.255.255.0, we're just going to write a /24. And this 24 represents, as I mentioned, 8 bits of 1, 8 bits of 1, 8 bits of 1.0. And I want to make this point a little bit more clear because you will see this representation, especially from folks in IT. So let's just erase this really quickly, make sure that it is clear for someone that's a little bit new to this topic. So 255.255.255.0 is one of the most common subnet masks that you will see in the industrial automation, especially on the private side. So this 255, like I mentioned, 2, 3, 4, right? So in binary, it's going to be basically 8 repeated 3 times, .0, and so the total number of ones is .24, right? So when you look at some of the specifications of IP addresses, you will use this nomenclature. So similarly, if you have something like this, so .0.0, this is going to be basically your /16. So 8 times 2, 16, and you can have anything in between, like I've mentioned. If this is something like so. 1, 2, 3, 4. This is going to be basically /20. Now, if you're just getting started, what I would usually recommend is that you leave the subnet mask, at least for now, by default to 255.255.255.0. You can experiment just for lab purposes, but like I said, there's going to be reasons as to why you simply do not want to put as many devices on your network as possible. And so let's look at some practical examples, right? So if you set your IP addresses just as we did in the lab a couple of lectures ago, what is going to happen, right? So 192.168.1.7 was the VFD, and this was, remember, /24. So if we set the laptop 192.168.1.100/24, that is perfect. As we've seen the demonstration, we were able to ping both of those devices, right? So this is perfectly acceptable. This is going to communicate. If we add another device, again through a switch, but to 192.168.2.100/24, is that device going to be able to talk to the other two? And the answer is no, because the third octet of the IP address is going to be masked by the subnet mask, and it's not going to be able to communicate to either one of these devices, right? So I'm going to put X's here. If we take another approach, right, so let's assume that we now change the subnet mask to be /16, so right, so 255.255.0.0, so /16. Well, then it becomes perfectly possible and acceptable for those devices to communicate, because again, you're only masking the first two octets in each case, and so everything will communicate. And this is theory. I don't expect you to memorize or to know very well. What you need to be learning and practicing is setting IP addresses. You need to be very careful not to ever set the same IP address on the network. You need to know the ways of setting IP addresses for different devices. Again, that's going to be based on the manufacturer, and you need to understand subnet masks so that you can, at least in theory, be able to figure out, is that IP address going to be relevant? What IP address do I set my laptop to in order to communicate to? And as we progress, there's going to be more and more knowledge that builds on top of these fundamentals. But if you have any confusion, don't hesitate to reach out, leave us a question, and we'll make sure to answer it.